All right, so that's good. Then loss function, I think we have already discussed. Cross entropy is a pretty good loss function to use for classification. And this is a very general formulation for a loss function where this is your input data, network weights, and this is going to give you network prediction. And your loss function is just going to compare that network prediction with the ground truth. Okay, so for classification, usually a cross entropy loss is pretty powerful. And this formulation, again, I think we have discussed already in this course. I have explained like why this cross entropy works for classification. Okay, I think ran through some of the trivial corner cases. And then that's all you need, right? You have a loss function, then you just train with gradient descent. And of course, for training, you have a lot of optimization algorithms. So you should not worry about this because again, this is like these are advanced topics. And for a course project, even for a programming assignment, you can just pick any one of these, even if you use SGD, that's perfectly fine. But the good thing is, like what are the different parameters you need for your optimizer, right? Like the learning rate or the decay and the momentum, all those things. And at the end, like if you have a CNN, you know that what you're learning, you are actually learning those kernels. And those kernels are, again, just trying to find that kind of pattern in the input images. And that's all what is happening. And everywhere it's filtering is happening, right? Basically, like the core operation is filtering. And the only question is what exactly we are filtering. In the initial layers, we might be just filtering these like basic shapes, these edges, right? Or color patches. And in the deeper layers, we might be filtering these complex shapes. And at the end, depending upon if you are able to find this pattern or not, the network will make its predictions.